The crow lands on the fence post and looks at you. Not past you. Not through you. At you. There is a quality to that gaze that stops most people mid-step, a stillness behind the eye that registers as something uncomfortably familiar. You feel observed in the way you feel observed by a person who already knows something about you and is deciding whether to share it. That feeling is not paranoia. That feeling is entirely justified. Crows remember faces. Not vaguely, not approximately, the way a dog might remember a general shape or a smell attached to a threat. They remember with the kind of precision that humans associate with long grudges and deliberate revenge. If you run a crow, the bird files your face away in a neural architecture that researchers have spent years struggling to fully understand. It will know you a week later, a month later, 3 years later. It will know you when you change your jacket, when you cut your hair, when you age another decade into a softer version of yourself. The file stays open. How that became known to science is a story that starts not in a laboratory but on a university campus in Seattle, where a researcher named John Marsleff began trapping crows to ban them for population studies. The trapping itself was routine fieldwork. What followed was not. The crows on that campus started behaving differently around Marsleff and his team. They would scold them, loudly and persistently, long after the trapping sessions had ended. To test whether the birds were reacting to the people specifically or to something else, Marsleff designed one of the stranger experiments in recent behavioral science. He and his colleagues wore rubber caveman masks when they trapped and handled the crows. The masks were distinct, recognizable, genuinely unsettling. The trapping happened. The masks came off. The researchers returned to the campus in ordinary clothes. The crows still scolded them. Then Marsleff reversed the variable. He had people who had never trapped a single crow put on those same caveman masks and walk through the campus. The birds dove at them, mobbed them in coordinated passes that looked nothing like random aggression. The crows had transferred the threatening identity entirely to the mask, divorcing it from the individual body, the individual smell, the individual gait. What mattered was the face. Only the face. The mask had become the enemy, and the enemy was permanent. This was not anecdotal. The experiment was controlled, repeated, extended over years. New birds joined flocks that had never witnessed the original trapping events. Yet young crows who had never encountered Marsleff's team and the caveman masks were scolding those masks within a few seasons. The knowledge was passing from bird to bird through a process that looked uncomfortably like teaching. Parent crows alarming at the mask, young crows reading the alarm, learning the face, adding it to their own personal threat inventory. A face. Passed down like a warning. Like folklore. The anatomy that makes this possible sits in a part of the crow brain called the palum, a region that performs functions in birds that the cerebral cortex performs in mammals. For a long time, the scientific consensus treated bird brains as structurally primitive, too compressed to support sophisticated cognition. That consensus collapsed under the accumulated weight of behavioral evidence. The palum of a crow is dense with neurons arranged in configurations that allow for exactly the kind of abstract processing that facial recognition requires. You are not just a collection of visual features to a crow. You are a category with a history. Crows belong to the family Corvidae, which includes ravens, jackdaws, magpies, rooks, and jays. Within that family, the species studied most intensively have demonstrated cognitive capabilities that regularly force researchers to revisit their assumptions. They use tools. They plan for future needs. They hide food caches and actively deceive other birds, who might have watched them hide food returning later, when the observer is gone, to move the cache to a different location. That behavior requires holding 2 points of view simultaneously, the bird's own and the observer's, and acting on the gap between them. That is not instinct. That is something else. Memory and identity tracking feed directly into the social architecture that makes crow communities function. These birds live in complex multi-generational groups where relationships matter, where past interactions shape future encounters. The face of an ally is as important as the face of a threat. There are documented cases of crows that brought small objects to the doorsteps of specific humans who had been feeding them, apparently as a targeted exchange directed at a known individual rather than a generalized appeal for food. The gift was addressed. What sits underneath this behavior is a theory of other minds that most animals simply do not demonstrate. The crow models what you know, what you intend, what your presence historically means. It maintains a running account of you as an entity with continuity, an entity whose appearance has predictable consequences because of what happened last time. When the consequences were bad, the account goes into deficit. The crow operates from that deficit with a patience and consistency that outlasts most human grudges. The neural basis for this kind of memory is partly tied to the hippocampus, which in corvids is proportionally enormous compared to their body size. Food caching species need to remember hundreds of precise spatial locations across seasons, and the hippocampus scales accordingly. But the hippocampus is also deeply involved in episodic memory of specific events tied to specific contexts and times. Research into corvid memory has produced strong evidence that these birds possess something close to episodic recall, the ability to remember not just what happened but when and the circumstances surrounding it. The technical term researchers use is episodic-like memory, the qualifier inserted to preserve scientific caution about animal consciousness. But the behavioral evidence is consistent and repeatable. A crow that watched you harm another crow, or trap it, or simply startle it, will remember the event, the location, the time of day, the face attached to the action. That event will be retrievable years later. The retrieval will be accurate enough to produce targeted behavior the next time that face appears. The mechanics of how crows pass this information socially involve recruitment calls and alarm calls that carry enough specificity for other birds to orient toward a known threat rather than a novel one. The mob forms around a face that most members of the mob have never encountered. They are acting on inherited testimony. This is a form of culture. The word has to be used carefully because it carries freight from its human applications, but the functional definition socially transmitted information that shapes behavior across individuals who did not directly acquire the original experience fits corvid facial memory transmission with uncomfortable precision. What the community carries from generation to generation is not just technique. It carries portraits of enemies. It carries the record of grievances. Ravens, the largest corvids and arguably the most cognitively complex, add another layer. Their social structures are built around long-term pair bonds and multi-year group relationships, and within those structures, they demonstrate what researchers have called a sophisticated understanding of social hierarchies in third parties. A raven that watches two other ravens interact can update its own behavioral model of both birds based on the outcome. It tracks not just its own relationships, but the relationship network around it. Each face is positioned within a web of alliances, rivalries, and obligations. Konrad Lorenz, the Austrian ethologist who made foundational observations of animal behavior through most of the 20th century, kept ravens and jackdaws and documented their individual recognition abilities decades before controlled experiments caught up with the anecdotal record. Lorenz described jackdaws that remembered specific people who had handled them roughly and responded to those people with directed hostility years afterward. He was building a portrait of a social intelligence that the mainstream scientific community was slow to accept because it contradicted the prevailing model of animal behavior as essentially mechanical. The prevailing model was wrong. What Lorenz was seeing, and what later researchers confirmed, is a form of social cognition that evolved not because corvids needed to navigate their relationship with humans, but because they needed to navigate their relationship with each other. Humans became legible to the crow brain because the crow brain already possessed the architecture to make any persistent, individuated agent legible. You are, from the crow's perspective, a large, persistent social agent with a history. And history, in the corvid world, has consequences. Bird banders, wildlife researchers, and ordinary people who fed crows and then stopped have all reported behavioral shifts following specific negative encounters. Birds that had been tamed became wary after a single rough handling and remained wary for years. Neighbors of people who had harmed crows began reporting the same bird swooping at them during nesting season, the directed aggression expanding through a social map that placed the offender at its center and rippled outward. Nesting season matters here. Crows become significantly more assertive in defense of territories and offspring during breeding, and if the individual associated with a threat lives within ranging distance of a nest, the attention becomes intensive. Crows will follow a remembered threat. They track movement patterns and appear with an anticipatory quality, arriving at a location just before the person they are tracking reaches it. This is surveillance. It is patient, it is persistent, and it runs in both directions. The same cognitive architecture that makes crows register threats also makes them register benefactors. The people who feed crows, who maintain regular positive interactions, who behave consistently across many encounters, enter the other column in the ledger. Crows bring gifts to regular feeders, warn known allies of approaching predators with calls that differ from generic alarms, and in documented cases actively intervene when a known human ally is being approached by something the crow has categorized as dangerous. There are accounts of individual crows in urban environments that learn to drop hard-shelled nuts onto pedestrian crossings and retrieve the crushed contents when the light changed. This behavior, documented in multiple locations independently, required modeling a complex causal chain across time and using human infrastructure as a tool within that chain. A bird that understands traffic lights as a mechanism within a broader human system is tracking human behavior with a granularity that most people do not apply to their own neighbors. That granularity is what makes the facial recognition so consequential. It is not an isolated trick, a narrow specialization that happens to involve faces. It is one expression of a general social intelligence oriented toward everything in the environment that has consistent identity and consequential behavior. Your clothes change. Your voice changes with mood and health. Your smell varies with diet and season. Your face, within the range of natural aging, is you. This is, incidentally, how human facial recognition works. The primate visual system has a dedicated cortical region, the fusiform face area, that processes faces as a special category requiring different neural treatment than other visual inputs. That selectivity is evidence of an evolutionary pressure strong enough to carve out dedicated neural real estate. The pressure was social. Faces carry identity, intention, emotion, and history in a dense encoding that nothing else in the natural environment replicates. Corvids arrived at the same solution through a completely different evolutionary lineage. The mammalian cortex and the avian palum are built differently at every level of organization. Yet both structures converged on the recognition of faces as a fundamental cognitive priority. The same pressure, the same solution, 500 million years of divergence between the lineages that produced it. Convergent evolution means that certain solutions are not accidents. It means that certain pressures, given enough time and enough variation, will find their answer regardless of the starting material. Facial recognition evolved in social primates and in social corvids, separately, for the same underlying reason. The crow looking at you from the fence post is running an algorithm that your own brain runs. The algorithm has been running, in both lineages, for millions of years. What the experiment in Seattle revealed was not that crows are doing something extraordinary. What it revealed was that crows are doing something deeply ordinary in the evolutionary sense. They are keeping track of who did what, and what that means for what comes next. The span of time across which they keep track is what surprises people. 3 years is the longest confirmed duration in controlled studies, but confirmed duration is bounded by the length of studies rather than the length of memory. Crows in the wild live up to 15 years. Ravens live longer, with captive individuals documented past 30. There is no mechanism researchers have identified that would cause a crow to forget a face on a schedule. A face that reappears, even after years, apparently reactivates the stored association. The years of absence are irrelevant. The account resumes where it left off. The city of Tokyo employed dedicated crow management programs as urban crow populations grew through the latter decades of the 20th century. The birds have learned to exploit the food system with a sophistication that outpaced initial containment attempts. When management strategies changed, the birds updated their behavioral models. When particular workers intervened more aggressively than others, those workers entered the threat registry. Crow management workers reported a sense of being individually tracked by specific birds, of encountering the same birds in different neighborhoods as if followed. The city employs people to disrupt the crows. The crows employ their facial recognition system to identify and track the disruptors. The Tower of London has maintained a resident raven population for centuries. The birds are individually named, individually tracked, individually assessed for behavioral health. They know the schedules of everyone who works within the tower grounds, the routines, the exceptions, the individuals who are consistent, and those who are erratic. One raven master documented a raven named Merlina who had developed a strong aversion to a specific staff member and would harass that person with a consistency and creativity that included genuine improvisation, new approaches, new angles, new timing calibrated to catch the target off guard. A grudge with a tactical intelligence behind it. The raven is not operating from rage. That is the critical distinction. The tactical quality of corvid antagonism toward remembered threats is not the product of an animal in continuous emotional distress. It is the product of an animal that has categorized a threat, stored the information in long-term memory, and applies behavioral responses when the associated face activates the category. The implementation can be creative, escalating, and persistent because creativity and persistence are within the behavioral repertoire of an animal with flexible cognition and no strong competing motivation in that moment. This is what makes it feel personal. It is personal in a specific and limited sense. The crow has made you a category. The category has properties. The properties determine behavior. The relationship between you and that crow, whether you know it or not, has a structure that persists through time, through absence, through change in your appearance or circumstances. You are in the ledger. The ledger is patient. And somewhere in the distributed memory of the corvid community that shares your neighborhood, your street, your park, the record of every significant encounter you have had with every crow that was watching is cross-referenced, transmitted, updated, and held in a collective account that will outlive the individual birds who opened it. The crow perched on the power line above you right now may have learned your face from a crow that has been dead for 2 years. The information transferred cleanly. The file is current.